Are 3D prints flammable? Well, I wanted to find out, so I tested a huge range of different 3D printing filaments to see if they're at risk of catching fire. And it turns out the answer is a lot more complicated and a lot more interesting than I expected. 3D printing is an incredibly useful technology, and I use it extensively for my electronics projects and more recently, fully 3D printed combat robots. But electronics can overheat, circuits can short out, and in the case of combat robots, these prints could literally be blasted with flame. And I don't want my 3D printed chassis turning into a 3D printed inferno in the arena because I chose the wrong material. And it turns out there's actually not a lot of information regarding 3D print flammability other than the very obvious point of burning plastic bad, so I set out to safely test a range of common filament types to see how they react to a naked flame. But I'm not going to downplay it. Burning plastic is indeed very nasty, and it can release a whole range of toxic byproducts, depending on what kind of plastic it is, which is why I built this testing rig. This setup comprises of a high-power laser cutter extraction system, which has a pre-filter, large HEPA filter, and activated carbon layer to trap any volatiles, and this filtered air is then extracted out of my open garage using a worksite extraction system. And for good measure, I also have a respirator, and I've got a fire extinguisher nearby, just in case. I put effort into this setup, but I'm by no means an expert, so don't try and replicate these experiments or base any mission-critical 3D prints of the findings in this video. So let's kick things off with some direct flame tests, starting with a lighter and then working our way up to a blowtorch to see if the material can sustain a flame. And the most popular 3D printing material by far is PLA, or polylactic acid, and its mysterious sibling, PLA+. But what does the plus actually stand for? Well, it beats me. Companies all have their own secret blends of PLA+ to make it stronger, print faster, and most importantly, look as pretty as possible. And they're all a little bit different. So I decided to test a few different PLA filaments from a range of suppliers, and we'll kick things off with this yellow roll from Elegoo. This particular PLA+ has been my go-to for plastic combat robots because of how strong it is. So it's obviously got other things in it, but whatever it's made from, it burns really easily. It didn't take long at all for the lighter to ignite the little cone, and it just kept burning and burning and burning. It wasn't an overly clean flame either, and it did not self-extinguish, so I had to put it out with a glass jar. That's good to know. The next PLA is Prusa's Prushiment Galaxy Black. This is by far one of the prettiest PLAs on the market, and it prints really well too. It has a black translucent look with those little sparkles to help hide the pesky layer lines. And when subjected to the lighter for a few seconds, it would instantly self-extinguish. So I stepped it up to the blowtorch, and something really interesting happened. It looks like there's no flame, but if you look closer, it is actually burning. The blue flame is really hard to see, but it's definitely on fire and melting rather fast. I turned down the lights and zoomed in to see what was going on, and I was mesmerized by the sparkly particles swirling around below the blue haze as the print melted like a candle. And once it was extinguished, the print cooled and hardened into a smooth and shiny surface with no charring at all. A very different result for a material that many people treat as the same thing. The final PLA I tested was this special roll that I picked up from Protopasta when I visited them back in 2023. This is a, quote, still colourful spool of HT PLA, which is Protopasta's way of reducing waste by saving the molten plastic that's used to purge the extruder lines between different colours. It didn't want to burn with a lighter, but with the blowtorch, it kind of sustained a similar flame to the Prushiment PLA, a barely visible blue one, but it didn't last nearly as long. The print also seems to live up to its claim of being HT, or high temperature, and this is even without any annealing, because it didn't seem to deform quite as fast as the Prushiment PLA when being blasted with a blowtorch. There are many permutations of PLA on the market, and I could never test all of them, but I just really wanted to see what a silk PLA would do. This shiny pearlescent pink PLA is one of my original rolls from Polyalchemy, the company that basically invented silk PLA all those years ago and sadly no longer exists. This roll is so old that it had become stringy and brittle and printed terribly, so I did what I almost never do with PLA and I stuck it in my filament dryer. And you know what? It actually did a pretty good job cleaning it up. The dried print looks a heck of a lot better, but does whatever they add to make silk PLA shiny change how it burns? Well, the filament went out instantly with the lighter, but after a full blast with a blowtorch, it did sustain a small yellow flame for a little bit before self-extinguishing. Once again, quite a different result, but it's kind of weird how it melts into these brown blobs. The internet tells me that pure PLA can be safely incinerated with no overly toxic byproducts, but none of these are pure PLA, are they? They all have additives and pigments, which will affect what is released when they burn. And honestly, I have no idea what they're adding. So if you're printing with these materials and there's a risk of them burning, keep that in mind. But before we move on to the next filament, you know what doesn't burn at all? Metal. And you can make your parts out of real metal using this video's sponsor, PCBWay. Even though 3D printed parts are finding their way into a huge range of industries, there's still no better option than CNC parts when you need ultimate strength. And PCBWay is your one-stop shop for CNC machining, PCB fabrication, 3D printing from a range of industrial processes, including metal, and much more. I've been using PCBWay for years now to bring my combat robots to life, and let me tell you, their parts have endured some crazy high impacts. Using their services is super easy. You simply select your process that you want to use, and then you upload your design. From here you can choose what material you want to use, what finish you'd like. You can even specify tolerances and more with a measured drawing. An engineer will then review your quote and help you figure out any design changes that may need to be made before production. You can use code PCBWay-MakersMuse-10 to get $10 off any order of $30 or more, so why not check them out in the video description below to learn more, and a big thanks to PCBWay for sponsoring this video. Anyway, now to everyone's favorite in-between filament, PETG. PETG or PETG or polyethylene terephthalate glycol. How are you meant to even say that without spitting all over the place? This is a very popular filament because it's not that much harder to print compared to PLA+, but it resists higher temperatures and it makes for strong and dimensionally accurate parts. You do need to dry it before printing, but transparent PETG is also the perfect choice for light diffusion in your projects, like I used it in this giant RGB fan. It looks stunning, but what if, I don't know, your LEDs overheated and catch fire? Will the PETG burn as well? Well, I don't think so. I tested a sample of Prushiment PETG and I found it was very resistant to burning. The lighter could barely touch it, and when I used the blowtorch on the print directly, it did create these brilliant yellow flames which did catch for a second or two, but it then rapidly self-extinguished. But check this out, see that white haze on the part? If you've ever printed with PETG, then you might have seen this same white film smeared around the hot end. I certainly have. So even though your 3D printer isn't technically burning filament, it still is releasing all kinds of nasty things into your surrounding environment. And this is why you should never run a 3D printer in your bedroom or where you work. And personally, I've moved all of mine down into the garage and workshop where I have an active airflow and a HEPA filter filtering the ambient air, just in case. Next up is my arch nemesis, ABS, and its slightly lesser known cousin, ASA, that is acrylonitrile butadiene styrene and acrylonitrile styrene acrylate. These filaments are harder to print than PETG and PLA because they have a higher shrinkage ratio, but they do have a pretty decent toughness and they're less dense, which is why I used ABS for the chassis of my tiny plastic combat robot. It's lighter for the same amount of infill than a PLA chassis. But what would happen if my little robot came up against a flamethrower? This green ABS is an ancient roll from Hobby King, which has sat on my shelf for years, but it still seems to print totally fine. But oh boy, well, you look at that. ABS catches fire really easily. All it took was a few seconds with the lighter and it was off. And man, is it nasty when it's burning. The print releases a thick, acrid black smoke as the flame consumes the plastic, and even when I smothered the flame, it still put up a fight. Super disgusting. I hope that I don't have to deal with that in the combat robot arena anytime soon. But how about ASA? Well, it has similar properties to ABS, but it has much better UV resistance, so maybe that changes the way it burns. No. If anything, ASA seemed to be even more energetic, bubbling and spitting as that nasty yellow flame consumed it. It didn't get very melty, but I can see how a fire like this could get out of hand very quickly, and even with the jar cutting off oxygen, it did fight for a really long time before finally extinguishing. And for good measure, I also tried a sample of HIPS, or high impact polystyrene. I've actually been printing with HIPS quite a lot lately because of how well it sands and paints compared to pretty much any other filament I've tried, but just like ABS and ASA, it burns real dirty. And something all these three filaments have in common is their styrene component. There is an ongoing debate regarding the carcinogenic nature of styrene. Some studies say yes, very, others say not enough evidence, but really, I wouldn't want to be around any of its byproducts. I no longer laser cut anything containing styrene, and again, I'm taking full precautions with all of these tests, hence the respirator and extraction setup. Next up is our flexible friend, TPU, or thermoplastic polyurethane. This is the filament that inspired me to do these tests after watching the NHRL combat robot events where TPU-clad combat robots literally melt apart during brutal flamethrower fights. And sometimes they do remain on fire, but can TPU on its own do that? Well, at least in my tests, no. In fact, my samples of TPU were the least flammable out of all the materials tested, and even with the blowtorch, it instantly went out as soon as the flame was removed. Maybe if you got a whole molten pool of it going, it might catch and sustain a flame, but for my uses, I'm reasonably confident to continue using TPU for shock-mounted electronics. But we're not done with TPU because I remembered I have this amazing stuff, foaming TPU. I've been printing this Tech TPU Air like crazy in recent months because of its incredible properties, and it is really handy for lightweight, durable, and squishy components. And after the previous TPU test, I fully expected this material to act the same, but maybe just a little more melty. But yeah, no, that's not what happened at all. Check this out. This foaming filament caught fire super easily, and it kept burning. It's like some kind of toxic marshmallow, and I have no idea why this TPU burns so aggressively when the regular TPU didn't burn at all. So if there's any experts in the comments, I would love to get your input on why these two are so different. And that's a bit of a bummer as well, because foam TPU would be even more suitable for shock mounting electronics in combat robots. But if a speed controller goes up in flames, as happens a lot in robots, it might well take the bot with it if the foam burns. So that's a shame. But wait, it's bonus filament time. This is TPU's super bouncy cousin, PEBA, or polyether block amide. PEBA is another new filament that's gaining popularity for its super high energy return compared to TPU. Basically what that means is it bounces really well, and it has a much lower density. I've started to use it a lot in my combat robots as a lightweight TPU alternative. But it turns out that unlike regular TPU, PEBA actually burns in a really weird way. It took a little bit to light, but then it sustained this tiny blue flame that slowly spread down the print, and I mean really slowly. Interestingly enough though, when it got about halfway into the molten pool, it started to splutter and then died, and even using the blowtorch, I was unable to restart it for more than a few seconds. It actually seems to strobe for ages before going out as well. Super weird. But of course, literally lighting things on fire is only one way of testing flammability. The other way things can burn is through something called autoignition. This is where a material gets up to a temperature where it just spontaneously ignites, no external flame required. All of these plastics have an autoignition temperature, and some are really simple to find, like with Prusa's PLA, the MSDS conveniently lists what the autoignition temperature is, 388 degrees Celsius apparently, but other filaments like my TPU I tested, no idea. So I figured the fairest and most realistic test would be to simulate a 3D printer failure where the heat cartridge comes into contact with the print at full power. And 3D printers have actually caught fire in the past from similar failures. So I subjected all the filaments to the heat cartridge at full power, and a lot of melting occurred, but in all of my tests, I was unable to achieve autoignition. All of the test samples made plenty of nasty smoke, though I would say not as nasty as when they were physically burning, but the heat cartridge did get up to a dull red glow, which means it was well above the 400 degrees Celsius or so that you would theoretically need to autoignite at least some of these filaments. But alas, even the foam TPU didn't autoignite. But that's not to say it can't happen, because there's a combat robot called Buffalo Wings, which uses automotive glow plugs as heat weapons, and they get super red hot, heating up to around 1000 degrees or so. And you can see in its fights that 3D printed plastic can indeed ignite instantly on contact with temperatures this high. I saw a lot of melting across all of its fights and plenty of flame as it did so, but as far as I can tell, that fire rarely, if ever, sustains itself once the heat source is removed. I didn't really know what to expect going into this, but some of these results really surprised me, and I'm glad I did the tests so that you guys don't have to find out the hard way when your electronics project goes up in smoke and then your control box goes up with it. To me, PETG seems like a really solid bet compared to ABS or ASA, which burnt really nasty. And TPU actually surprised me. I fully expected that to go up, but yeah, it didn't. Except the foam TPU. That one's a real shame. And the fact that we don't really know what's in any of these PLA pluses actually concerns me quite a bit, because they all behave differently. And yeah, all burning plastic is bad, but some are much more bad than others. Again, I did as much research as I could before starting this experiment and subjecting these materials to fire, but there are some super nasty materials that I didn't include in my test, and you'd never want to be around if they're burning. These are plastics like PVC, which releases hydrochloric acid when burnt, or POM, which literally releases formaldehyde gas. And then there's PTFE, which is the same material that often lines 3D printer hot ends. This effectively releases a nerve agent that's 10 times worse than phosgene when it burns. I'm not even kidding, please look that one up, because PTFE is quite concerning. And yes, you can buy filaments that are flame retardant, but rather ironically, the flame retardant additives themselves are super toxic. So I'm not really game to try and burn them, because I'm not really sure which one is worse. If I've learned anything from my research into this topic, it's that we don't really know the long-term health effects of working with plastic, whether it's burning or melting out of a hot end. But it's safe to say that you want to minimize your exposure as much as possible. So again, please keep your 3D printer in a well-ventilated area, and if you do need parts that must survive high temperature environments or direct flame contact, then there really is no better alternative to real metal parts. So check out PCBWay at the link in the description below to see how they can help make your project a reality. Thanks for watching, guys. Bye.